Okay, so today we're going to talk about trig functions 1.6. So this should be all review and stuff that we did before already. So we're going to just kind of go through this pretty quickly. So let's see what we have. 1.6, radian measures. Example number 1, finding the arc length. Finding the arc length. Arc length, if you remember correctly, this is what we're going to have here. Okay, so the arc length S is going to be the radians times the degree, so it's going to be like that. So we're going to have, it's going to be the radius times the amount of radians, right? So find the length of a subtendon on a circle, radius 3 by a radians of 2 pi times 3. So the radius is 3, 2 pi over 3. Looks like it's going to be 2 pi, okay? Then we're going to talk about graphs of trig functions. So let's kind of briefly go through our graphs. So a sine graph is going to look like this, where 0, 2 pi, pi, and 2 pi, right? So it's going to go between, cycle between positive 1 and negative 1. So obviously it's going to be extended out back this way too and go like that. So the period, or the amount of time it takes for it to repeat itself, is from here to here is where it repeats itself again. So my period is going to be 2 pi. So y is equal to sine x has a period of 2 pi. It is bounded by positive 1 and negative 1. So the domain is all reals, where the range would be between negative 1 and 1. So that would be our sine graph. Cosine graph looks very similar. Cosine graph is going to look like this, but it starts here, right? So 0, pi over 2, and this is where we actually repeats itself in 2 pi, so this would be 3 over pi over 2, and this guy here would be pi. This is y is equal to cosine x. Again, the domain is all positives, all reals, where the range is going to be between negative 1 and positive 1. And the same period, 2 pi, takes 2 pi for it to repeat itself. Okay, so that's cosine. And then we have the tangent graph. The tangent graph looks like this. Negative pi over 2, pi over 2, and it repeats itself again and again. So for tangent graph, okay, our domain is going to be what? X cannot be, because we have asymptotes here, right? Asymptotes can't be this plus or minus n pi. So every pi we're going to have an asymptote. Okay, we're going to have an asymptote there. So that's going to be the domain. The range is going to be all reals. It's going to go all the way up to positive infinity down to negative infinity. Right? So that's what that looks. I am not going to go over the other ones. You can do that at your own time. So that'll be the secant, the cosecant, and the cotangent graphs. Okay. So those are basically the trig functions. Okay, and then so on the middle of page 46, there's a green box that says the periodic function and what the period is. And then we talk about even and odd functions, right? Even and odd functions. So even function, odd function. Even function is symmetric across the y-axis, where the Odd function is symmetric across the origin. Okay, so for our trig functions, the even functions are sine x. So y is equal to sine x is an even function, where y is equal to cosine x, or y is equal to tangent x, are both odd functions. They're symmetric across the axis. Okay, also, we talked about an even functions. An even functions, the definition of an even function is where this is the same as this. And in an odd function, this is going to be the same as negative f of x. So this is how you would determine whether a function is even or odd. Okay? Okay, so we're good with that. Now let's talk about transformations of the trig functions. Transformations of the trig functions. You can move the trig functions up and down, right? Or you can move it to the right or to the left. And the way we did that is, if you go to your book, we have y is equal to a sine bx plus c plus d. A is basically the amplitude. It controls the amplitude, right? How high am I going, up or down? So if I have y is equal to 2 sine x, now it'll be go from, instead of positive 1 to negative 1, we'll go from positive 2 to negative 2. So this controls the amplitude, right? And then you have another one, easy one is d. D actually shifts the graph up and down on the y-axis, okay? And then you have b, which controls the period. This controls the actual period. If you remember, the period is b is equal to, period is 2 pi over b, right? The period was that. And this, if you remember correctly, this was called, we had a special name for this. This was called the phase shift. So this shifts the graph horizontally to the right or to the left, okay? So those were what we had, okay? So let's see if we can do example number 4. Let's see if we can go over example number 4. See if that kind of jogs our memory here. Example number 4. Example number 4. Determine the period, domain, range, and draw the graph of the function y is equal to 3 cosine. Y is equal to 3 cosine 2x minus pi plus 1. Okay? So the thing that most people kind of get confused upon here is this. And this, you should actually view it like this. You're going to view this as 2x minus pi over 2 plus 1. Okay? So what happened? The amplitude is now plus 3 to minus 3, right? But I am shifting that up 1. So it's going to go between, instead of 3 and negative 3, it's going to go now from 4 to negative 2. Because this 1, we shifted it up 1 on the in the y direction. 2 is going to control the period, so the period is now 2 pi over 2, which is pi. Okay, and we shifted it in the positive direction because this is minus pi over 2. Okay. A, what are we trying to find? We're trying to find the period. We found the period right here. B, the domain. The domain is still all reals, right? Still all reals because it's a cosine graph. And then we want what? What else do we want? The range. The range is from 4 to negative 2. We did that up here. And then what else do we want? Draw the graph. I'll let you guys draw the graph. Okay, we'll go from there, and we move on to, let's look at the inverse trig functions. Inverse trig functions, okay, when learned the inverse trig functions, we had a mantra there that we were going to say, right? The mantra is that y is equal to arc sine of x. That means that is now the angle, this is the angle that gives me this value. It is the angle that gives me this value, okay? So when we're doing the, remember, if you remember correctly, the inverse functions of the trig functions had a specific domain and a specific range, right? And the reason being is if I use the entire sine graph, I cannot have an inverse function because although this passes the vertical line test, it does not pass the horizontal line test. In other words, remember, inverse functions, you had to have a one-to-one function, and to be a one-to-one function, you had to pass not only the vertical line test, but you also had to pass the horizontal line test. So for sine, we cut it off between here and here, okay? If you remember correctly, now for cosine, we cut it off from here to here. Okay, and in tangent, we didn't have that problem because in tangent, so in other words, the arc cosine graph that you will find later on will have different domains and different ranges. And that is on top of page 49. On top of page 49, it shows you the specific domains and the range. Okay, so review that, please. You'll review that and you'll probably kind of hopefully pick that back up. And that's about it. So we'll call it good here for 1.6.